Okay, so welcome to here we are now really in part 3 of the right triangle trig TOA. So we already did the so part, ka. We already did the ka part. Now we're going to look at the toa. The toa, oh, make sure that looks like an A there. The toa part, that's the part we're going to deal with. Okay, so here we go. What is toa? Toa stands for the tangent or the tan of an angle, just like the sine and the cosine, equals the, now we already know O from the so card, the O from the SOCA we already learned was opposite. It stood for opposite, and the A stood for the adjacent. That's kind of useful, right? It was the same letters. The O is opposite, the A is adjacent. And we also already learned that the O divided by H in the so, that it's always the fraction that you look at in this thing is the O over H. In the ka, it's the A over H. So the toa would be the O over A. So you have your opposite divided by your adjacent. So that's the actual equation. That's the formula. Let's go ahead and shrink this thing down in 2 parts here so we can, there. Okay, so now let's put it in triangle perspective. What does that mean in terms of a triangle? Of course, you have to have an angle and you have to have a right angle. Okay, we already know where the tangent is. The tangent is across from the right angle. And hopefully you're remembering back from the SOCA part where we talked about the opposite side. Well, the opposite was the opposite, right? Opposite, so we're going to go ahead and write that in. Opposite the angle in question. The A portion, the adjacent, we already talked about from the ka, and that's next to the adjacent. It is adjacent. So we have opposite and we have adjacent. Opposite, adjacent. Okay, so that is the adjacent. And that's talking about this length of that part of the triangle. So here we go. Oh dear. Move that, and then I got to move this part over here so that it fits a little bit smaller, a little bit smaller. There we go. Okay, so now let's talk about a question. Let's go back. Oh gosh, this is actually a more fun one. This is a little more practical because we can talk about like trees and surveyors and interesting things like that. So let's pretend for a moment, it's actually tangent's the one that I use most often, I guess, if I'm talking about using one of these things in everyday life. Let's pretend for a moment that you're a little guy standing over here and you are looking. See, you're looking with your binoculars. There we go. And you are looking up to the top of a tree. Okay, there's a tree, and we can then even draw in this little line here. Okay, now I guess I could draw in the tree and some of the other colors on this tree. See, here's the rest of the tree. Right, the tree's growing here. And we can even put in some green leaves at the top. Okay. Either way, there you are, looking up to the top of the tree, and you're going, huh, how tall is that tree? I don't know, but it sure would be interesting to find out. How tall is that tree? How tall is that tree? It's a good question. Well, we can go ahead and handle our handy-dandy little tape measure, and we can get a measurement of how far are we actually standing from the base of the tree. Let's see, and let's say that we knew that we were standing 100 feet away from the tree. Now, 100 feet, that's not really that far. 100 feet is like the distance between 2 telephone poles. It's not really that far. And because we were a surveyor, we would be using a thing called a plumb bob, so we could also figure out that this angle right here, that angle happens to be, that angle there happens to be, I don't know, it looks more like maybe a 42 2 degrees. Okay, so let's shrink that whole thing down. There's our nice little question. How far to the top? Well, I am going to use this because the 3 parts I've got are I'm looking at the angle. I'm interested in the opposite side, which is the height of the tree, and I have the adjacent. So the 3 parts are here. If those are the 3 parts, and I don't really care what the hypotenuse is, then you have to use tangent. Tangent says with these 3 parts, use the tangent. Okay, so here we go. So let's just fill it in. Tangent of 42 degrees equals the opposite, which is I'm going to use the opposite for O. That's not a 0, that's an O. And then I'm going to go 100 on the bottom. So it's not 0 over 100, that's O over 100. Now, of course, we know that we can end solve this thing, so I got to shrink it down, put in an end solve in front, and because my O, that's an O, not in a 0. Someone I'm sure is going to speed over this and think that that's a 0 and screw up the whole thing. Just don't let it be you. I'm going to press pause. Okay, so continuing this thing, I typed this in. Remember, we did end solve equals the tan of 42 degrees. Don't forget the degrees of O divided by 100, not 0, comma O, because O, the letter O, is the variable. And what did it give me? It gave me that this tree is 90.04 feet tall. Why do I know it's feet? Because the units of this triangle are going to be in feet, because it says right there, feet, 100 feet there, 190 feet there. It's like, oh, cool, I know how tall the tree is. Woohoo! Okay, here we go to the next page. Okay, so here we are, no blank page. Again, if you're not taking the time to write this out, the reason that I'm remembering it so well is because I write it out so many times. Just pause the video, write it out again, because the more times you write it out, the more likely you'll be to remember that you're writing it wrong on a test. The TOA is what we're looking at. The TOA, which means the tangent of the opposite over the adjacent. Opposite over adjacent. Tangent of what? Tangent of an angle. It's always the tangent of an angle. Okay, so what do we got? There's the angle, we have the opposite side of the angle, adjacent side to the angle. Or this thing over there, that is the hypotenuse, because it is across from the right angle. It's across from the right angle. So here we go with the next question. Let's say that you happen to be knowing some interesting facts. We need a big triangle. And you happen to know that this building over here, I don't know, there's some windows in the building. You happen to know that that building is 300 feet tall. Wow, it's like a skyscraper. And you're going, oh my gosh, how far away am I from it? I don't know. How far away am I from that building? And you, of course, break out your trusty little protractor, and you can measure this angle here, angle here, is maybe something like, I don't know, 24 degrees. You measured that. Okay, so here we go. That's the question. How far are you from the building? Okay, so we're going to use the TOA part because, again, we have the opposite and the adjacent. The opposite and the adjacent. I don't care about the hypotenuse, but I have these over the opposite and the adjacent. I've got an angle, so use the tangent. So here we go. Just write it all in. Tangent of 24 degrees is equal to 300 divided by the adjacent. I'll use the letter A, and of course we're going to go ahead and shrink this down. I'm going to press pause, and I'm going to end solve this whole. Okay, so you see here I went ahead and did end solve tangent. I didn't forget my degree symbol over A. A is the variable in this equation, so I need a comma A, which of course gave me the whopping grand total of I am how far from the building? I am 673.811 feet away from the building. And how do I know it's feet? Because this part is feet. If the building was 300 feet tall, so all elements of this triangle in this example are going to be measured in feet. Because that's 300 feet, this must also be some answer in feet. So therefore the answer I got is 600 feet. Okay, I'm going to press pause, start one more so that you can do it. All right, so here we go with your question for the day. Remembering this is TOA. Right now we're working with the TOA part, which means the tangent of the opposite and adjacent. That's the opposite. Remember, there's my angle, the tangent of the angle, opposite that angle, adjacent to that angle. And then this thing over here, that's the hypotenuse, which is across from the right angle. Hypotenuse is always across from the right angle, but in TOA, we don't care about the hypotenuse. Okay, so here we go. Let's say you know a few things. You know that... well, let's do purple. Purple's good. Okay. You know that some flagpole, let's say a flagpole, is 100 feet tall. We need to draw a little flag at the top of that guy because all flagpoles need little flags. Here we go. Flag. There's our flag. There's our flagpole, right? And a little dingle ball at the top. There's our flagpole. Okay, so we got some kind of flagpole there. And we know that it's 100 feet tall. We also know that we happen to be standing 150 feet away from the flagpole. Okay, we're standing 150 feet away from the flagpole. What we want to talk about is the angle of elevation. Okay, that's actually a fancy way of saying that right there. What is the angle of, I think it's important if I'm actually going to write that down. What is the angle of elevation, E-L-E-V-A-T-I-O-N. Bam, that's the question. Angle of elevation, that's it. It's just the angle above the ground. If you think I'm going to stand on the ground, I'm going to go elevate my eyes. So what's the angle above the ground? So you got to look up to see that. That might help you actually do that. Remember that. So there's the question. Well, actually, you're the one doing this one. So go ahead. Don't forget, fill out all the parts. Use the formula. Fill out the parts. Show your work. I'd suggest end solve and tell me what is the angle of elevation for this question. All right.